Okay, so I believe, if I'm not mistaken, let me, I'm going to check this out so I'm not, because I think this is the last week of new material. So let me just jump down in my pace chart here. Okay, so week number 12, okay. Yep, and then everything else is going, so week 13 and 14 we'll be just reviewing, and then week 15 is the final, or the semester, or the AP exam. And I believe the AP exam is on Monday this year, isn't it? Are you taking the AP exam? And I believe it is on Monday, yeah. So that would be week number 15. So so this is the last of the new material, and then weeks 13 and 14 we're just going to review. And then week number 15 on Monday is the AP exam. Okay, so first problem. You are not able to do part B yet. Okay, so I'm going to cross off part B. So this is how the AP exam is set up. You have two problems that you end up using your calculator on, and then two that are four non-calculator type problems. And I'm not 100% sure if this was a calculator-based one or not. I don't think it is. So why don't you do part A and part B, and don't use your calculator. See if you can solve those and get the correct answer, okay? And then we'll go through them. I'm only going to give you maybe 3 or 4 minutes, which probably isn't enough time. Usually you get about 15 minutes for each free response question. So I'm kind of pushing you along here so we get everything done today. I'm not even gonna give you 3 or 4 minutes. Okay, sorry, but hopefully you can follow along here. And if you have any questions, please ask. Now this is a type of problem. It says find the area of R, and so you really have to understand what the graphs look like, because obviously in this problem you don't have the option of using a graphics calculator. So hopefully you know what the graph of these two functions look like. The square root of x would be this graph here, or something very close to this graph right here. And y is equal to x over 3. Well, that's the same thing as y is equal to 1/3 x. So it starts at 0, goes up 1 over 3. So it's going to look something like this. And then we have a point of intersection there, and we have a point of intersection here. This is R here. So in this problem, it says find the area of R. Okay, we learned that to find the area between two curves, we take the top function minus the bottom function. So in this first problem, it's going to be the integral from 0 to where it crosses. Well, how do I know where it crosses? Well, if you set your two equations equal to each other, so square root of x equals 1/3, it should tell us where they cross. So I'm just going to multiply by 3 here. So that's 3 square root of x equals 1. Square both sides. So what is that? 9x equals 1. So x has to equal 0. That is a value. So I know that this is going to be 0, 0 here. And I believe 9 would be my other answer here. Where did the x go for the 1? Oh, I'm sorry. Right there. It should still be there. And so when I multiply through here, I should have x. And then I square it. So when I square it, I end up with 9x equals, what is that, x squared there? Okay. And then if I divide through by x, I end up with 9 is equal to x. So my other value would be 9. Thank you for, oh, that's not 9, that's 9, 3 here. because if I put 9 back in here, the square root of 9 is 3. So this point here is 9 comma 3. Okay, so I have my 2 points. So now I've got the integral from 0 to 9, top function, which is the square root of x, minus the bottom function, which is x over 3. Now I have to take the integral of that, so I'm probably going to rewrite this as the integral from 0 to 9 of x to the 1/2 minus x over 3. So if I add 1 here, that gives me x to 3/2 times 2/3 minus x squared over 6. Is that right? I think so. From 0 to 9. Now you have to plug 9 in here, and hopefully you go back and do these problems slower when you have some time on your hands. Okay, so if I put 9 in here, 3/2, 9 to the 3/2, so that's what, 27. 27 times 2 is 54, so that's 54 over 3 minus 9 squared, which is 81 over 6. And then if I put 0 in there, that's just going to be 0. So my answer is just going to be this, worked out. I don't know if I can simplify that down any. 81, does 3 go in there? So let's see here. So I might just divide out a 2 on top and bottom. I can't do that. So let's see here, 54 divided by 3, so that's 18 minus, and then 81 divided by 6, 13.5. If I subtract that 18 minus, and you just end up having to do this, by hand, which would be 4.5 for the area. Okay, so that's finding the area. Now, the other one, we can't do part B yet. We're going to learn how to do that today. But part C, it says the region R is the base of a solid. Okay, so this is the base of a solid. The cross-section perpendicular to the y-axis are squares. Okay, so to the y-axis. So I'm going to do squares this way. I'm going to remember, all we have to do is find the formula for 1 square, and then I'll take the integral. But since it's perpendicular to the y-axis, I have to change my equations. I have to rewrite y is equal to the square root of x as, I'm going to square both sides, so that's going to be x equals y squared. Okay, and then this one is going to be 3y equals x. So if you're going perpendicular to the y-axis, you have to have everything as x equals instead of y equals. So this would be 3y here, and this would be y squared here. Well, what is the base of this thing? Isn't it just 3y minus y squared? And then I'm going to have to square that because it's a square. And then instead of going from 0 to 9, my integral is going to be from 0 to 3. It says cross-section of y-axis, find the volume of the solid. Okay, so I'd have to multiply this thing out, which probably is going to take me a while. So I'm not going to do that, but that is how I would set the problem up. All right, any questions on how I set either of those questions up? And now, as I said, on the AP exam, you have like 15 minutes to do each free response question. So that would give you the time to work that out. Okay, any questions on that? Okay, so here is the answer key for this problem. So you get 1 point just for writing down this here, or just to find the limits, knowing that it's from 0 to 0 and 9, 3. You get 1 point for that. 1 point to set up the integral, and then 1 point for the answer of 4.5. So you can see that you can get 2 points without even having to work it out. Part B we can't do yet. Part C, you got 1 point for setting up the integral. Now, if you didn't have time to solve it, that's 1 point. That's not a big deal. So this is really important to understand. If you can set the problems up but you can't solve them, that's okay. You would only lose 3 points on this problem if you did not answer them. If you just set the problem up but did not work out the answer correctly, you would only lose 3 points out of 9. That would still leave you with 6 points. So the best thing to do is try to set the problems up first, and then if you have time, go back and work them out. I know that this problem would take me a little bit of time to solve. Why? Because the first thing I'm going to have to do is I'm going to have to multiply this thing out. I'm going to have to go, oops, my marker's not on. I'd have to go 3y minus y squared times 3y minus y squared, and then I would take the integral of each one of those terms separately. So it would take me a while to do. It just, you know, I can get most of the points without having to do that. So, you know, if you're in a time crunch, try to set all the problems up. Okay, today we're going to talk about the volumes of rotation that have holes in them. Okay, so the first problem I want to do is I want you to get your calculator out. Okay, so I want you to solve this without a calculator, or with your calculator. 2, 3, 4. 1, 2, 3, 4. If I, and 1, 2, 3, 4. If I had this is a semicircle, okay? This equation of this that I just graphed is x squared plus y squared is equal to 16, okay? If I wanted to just write the top half of this circle, now, so this is a circle, right? Or a semicircle, if I rotated this about the x-axis, this whole semicircle, and I rotated it, what would that volume be? What would that figure look like? What would that figure look like? And it is a half a circle. Mine is a little bit more like an ellipse. But if you took a half a circle and you rotated that about the x-axis, what figure are you going to get? A sphere. That's exactly right. What is the volume of a sphere? Okay, what is the volume of a sphere? You know that? This is one of the things you're supposed to know. 4/3 pi, 4/3. You forgot the R though. How about 4 pi r cubed over 3? Or 4/3 pi r cubed. Okay, so in this problem, what is the radius? Four. Tell me what the volume is of this thing if I rotate it around the x-axis. If you just had to find it just using this formula, what would the volume be there? $85.33 pi. Okay, multiply the pi out also, because I don't want to leave pi in my answer. So what is that going to be? I think it's like 268. 0.08, 267. I think I had 268.08. All right. I used the whole pi. I didn't go 3.14. I just used the button on my calculator. So I'm sure mine's a little bit more accurate. All right. Now, if I was going to do this problem using calculus, I would need to rewrite this as y is equal to. And I can do that. Y is equal to 16 minus x squared, and then take the square root, right? That would be the semicircle. So if I wanted to find the volume of this thing using calculus, I would go integral from -4 to 4 of, and remember we have to have a pi out there also, because remember it's r squared from last week. So this would be 16 minus x squared, and this whole thing would be squared, which was kind of cool because then I could just get the square would take care of the square root. So it would be pi -4 to 4 of 16 minus x squared. Okay, I want you to plug that into your calculator. And I want to make sure you know how to use your calculator, first of all, in order to find integrals. So what do you get when you take the integral from -4 to 4 of 16 minus x squared and then multiply that by pi also? Let's see if we get the same answer, because we should get the same answer, right? Because it's using the formula or using calculus, 268.08. Okay, so we get the same thing using calculus or just a geometric formula. Okay, now this week, let's say I had another semicircle here. And that semicircle is x squared plus y squared is equal to, what is that? 3 squared, so that'd be 9. Okay, and I want to know what the area. So this would be, it would have a hole in it, right? So it would be like a beach ball with a really thick thick outer core. But do you understand what that figure would look like, right? So it's not a solid sphere anymore. It's just like a beach ball, but the thing is pretty thick. I mean the outsides. Yep. So how do I find this? That's this week's material. It is the integral. It's pi times the integral from a to b of the big radius minus the small radius. So the big radius is always the one from the bigger one. So in this problem, it's from here to here. This is my big radius. And the small radius would be this one. And what is this small radius? It would find the solid in the middle, and we're subtracting that off the big one. So really, you're left with just the outer portion, the volume of the outer portion. So in this problem, I would go pi and then -4 to 4, and then I would take my big radius squared, which is the square root of 16 minus x squared minus, and then my small radius squared, which is, what is that? That would be the square root of 9 minus x squared. So big radius squared minus small radius squared gives us the volume when there's a hole in there. Okay, so here are the notes. Okay, this is called the washer method because you're really going to end up with a hole in the middle there. And here's the formula. Pi times a to b, big radius squared minus small radius squared dx. So here's a problem. In this problem, and this is I think we already did this problem, but we didn't do the volume part. So I think we already found the area on one of your homework assignments. So we're not going to do that. But this one, it says write, but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y is equal to 7. So y is equal to 7 is way up here. So I'm rotating this figure around this line here. Okay. So whenever I do a problem like this, I always just draw on my radiuses. Okay, so here's my big radius. Here's my small radius. All right, now, it told me to write, but do not evaluate the integral. So I've got the integral from 0 to 9. I better put a pi out in front. Okay, what is big radius? What is this value here? Now, you're not going to come up with a number like 10 or something like that, but you're going to come up with an equation. 2 square root of x. I disagree with that. 2 square root of x would be this distance right here. From here to here. That gives you 2 square root of x. I want this distance. I want this distance from here to here. that. Okay, and this is where sometimes I disagree with that. Okay, this is where sometimes you just have to start drawing some things out. Okay, so let's say one of my equations is y is equal to 7, and my other equation is y is equal to 5. What's this distance here? What is the distance between y is equal to 7 and y is equal to 5? 2. How did you find that? Did you take the bottom minus the top, or did you take the top minus the bottom? Top minus bottom. So if I wanted to find the distance from here to here, isn't it 7 minus 2 to the square root of x? That's my big radius. Square it. Minus, what's the small radius in this problem? 7 minus 6, or 1. So this time I can find a value. It's just 1 squared, which is just 1. This is my formula. If I plug this into my calculator, I would find the volume of that figure. But it didn't ask me to plug it in. It says write, but do not evaluate. Okay? I'm going to tell you that there's a problem on the assessment this week that is probably one of my favorite, all-time favorite problems, and most kids are going to really freak out on it. Let's see if we have the, yeah, so down here, this is, so the volume, 7 minus 2 squared of x squared minus 7 minus 6 squared from 0 to 9, and you have to have the pi out there. All right, share a blank screen. Okay. Let's say I gave you okay, so I'm just getting you ready for the problem that I give you tonight that is going to drive me crazy. Let's say that this bottom line here is y is equal to 2. This vertical line is, let's say, x equals 3. And this line right here, the hypotenuse of this triangle, let's say, obviously it has to have a negative sign and a negative, so let's say it's y is equal to negative 1/2 x plus 4 or plus 6. Okay. So now I'm going to ask you to rotate this thing about every axis. Okay. So for example, if I take this triangle and I asked you to rotate it about the x-axis, write but do not evaluate. And let's say that this point here is 3, and let's say that this value here is 5, and over on this side, let's say that this value is 2 and this value is 4. Okay, so write an integral to find the volume of that triangle rotated about the x-axis. Okay, so I want you to rotate this about the x-axis. All right, so there's definitely a hole in there, right? I mean, this is a hole. This is definitely going to be a hole there. So how do I write that? I've got the integral, so I'm going around the x-axis. So integral from 3 to 5, and then it's going to be big radius is from the outside, small radius. Okay, so the big radius is just going to be negative 1/2 x plus 6. Squared minus the small radius. Well, that's just 2 squared. Done. That's my answer. But now, let me give you a hard one. What if I asked you to rotate that about the line y is equal to negative 3? Okay, so now I'm asking you to rotate this triangle around this line. Okay? So now, if you take a look at it, the big radius is going to go from here all the way down to here. And the small radius is going to go from here to here. So this is big radius. It never changes. It's always big radius squared minus small radius squared. So what is the big radius? This is where so many kids cannot tell me what that big radius is. What is the big radius? Negative 1/2 x plus 6 plus 3. Exactly. It's just getting 3 units larger, isn't it? Excellent. So this would be 3 to 5. Big radius squared would be negative 1/2 x plus, I'm just going to put plus 9, okay, just to make it shorter, squared, minus, what is the small radius? Two plus 3, which is 5. But it's squared. And remember, we have to have a pi out here. Oops, I didn't have a pi out here either. Okay. Now, I wish I could erase this, but I can't because it would erase the whole thing. What if I asked you to rotate that about the line y is equal to 10? Okay. So I'm taking this, I'm rotating it around this line now. So it's going to be pi, I'll start you off, 3 to 5. Okay, what's the big radius? So now the big radius is from here to here. It's not, no way. It's from see the black line? That's the large radius. The small radius is from here to here. So you always have to draw them in, whatever one's longer. Okay, so what's the big radius? Two minus 10, negative 8. You're saying that a radius can be negative? Remember, we did a problem just like this. It's top function minus bottom function. It's not bottom function minus top function. If you have something above, you better take that. That's the larger number. So that's going to be 10 minus 2. So this is going to be 8 squared minus, what is the small radius? And that's where you have to start thinking about how do you get that? Yes, exactly. It's going to be 10 minus, and then negative 1/2 x plus 6, and then that's going to be square 2. Big radius squared minus small radius squared. Plug it into your calculator. Boom, you get your answer. There is a problem on the assessment that is exactly like this. And then it'll ask you to rotate around the y-axis. Going this way, same thing. Small radius, large radius. The only problem is, if you're rotating around the y-axis, you have to rewrite the equation so it is x equals. Okay? So that's the one key. If you're rotating around the y-axis, it's got to be x equals. All right. Whew, I love that problem. You'll see it on the assessment. It's a great problem. It asks you a bunch of questions. Okay, I've got to get back to our assessment or our thing here. Okay, so we did that problem, we did that problem, we did that problem. All right. So this one, I don't want you to find the area. You obviously can come back and do that. It's just we just don't have that kind of time. So we won't find this one, finding the area. I can do it real quick. I'm just going to set it up. So this is natural log of x here. This is x minus 2 here. If I want to find the area, you're going to, this type of problem, you know how to graph on your calculator, correct? Okay. Do you know how to find the points, like where they cross? You know how to do that. Okay. So in this problem, it's a little tricky because you'd have to graph it out and then you have to find the points of intersection because they don't give them to you and they're not nice. I don't know what the points of intersection are, so I'm just going to use A and B. So if I wanted to find the the area of R, I would just go the integral from a to b, top function, natural log of x, minus the bottom function, x minus 2. Boom, that's the area. Now, if I couldn't solve it, you know, I would just leave it like this. Problem number 2, it says find the volume of a solid generated when R is rotated about the horizontal line, y is equal to -3. All right, so -3, y is equal to -3 is going to be down here. Okay, so if I wanted to rotate that around that, okay, it's going to be big radius, small radius. So my big radius, okay, so it's top, and then it's going to be plus -3, isn't it? Because I'm adding that -3 onto it. So I'm going to end up with, so I don't know what the values are here. A to B, and then it's going to be natural log of x plus 3, because I'm adding, it's rotating 3 units down, and that's going to be squared, minus small radius, well, that's going to be, again, x minus 2 plus 3 squared. Boom. And that would be the setup. Now, in this problem, they did want you to come up with the values. So what I'm going to do is I'm going to let you play with this problem for a little bit, okay? I want you to find these values where it crosses, so I know you know how to find points of intersection. And then I want you to plug this in and see if you get the correct answer, okay? And then we'll talk about part C. Are you okay? Are you okay with that? With your calculator? Plugging all that in? Okay. And then tell me what you get for an answer there, and we'll see if you get it right. And I forgot to put pi out in front. I always do that. Right. So make sure you put pi out in front. Okay, so your points of intersection are, okay, let's see here. 3.14 and 1 point. So this one here is 3.14, comma 1.14, and this one here is 0.158 and negative 1.841. Okay. Okay. Now, what type of graphics calculator do you have? Okay. Do you know if you go to y1 and you put in natural log of x, and you go to y2 and you put in, what is the other equation? X minus 2. Then when you go down here, you can, instead of and this problem, it wouldn't be worth it because it's not, but sometimes you get some really long equations. But what you can do, what your calculator can do, you plug this in, you can tell your calculator, instead of using natural log of x, you can just say y1 plus 3 squared minus y2 plus 3 squared. So you wouldn't make a mistake. Now this works really nice when you have like really long equations. In this problem, the equation isn't that complex, so it really doesn't matter. But if you had to graph this out to find these points, you probably already have y1 equals natural log of x, y2 equals x minus 2. So it's just kind of an interesting way of doing it. Instead of having to type that equation back in, you can just put y1 there. Do you know how to do that? Okay. On your calculator, now I have a TI-83. If you take a look right below the arrows, you should see a button that says variables, right? VARS. Do you see that? If you click on it, at the top, you should see Y variables, right? And if you just click on that, if you just scroll, or if you just arrow over to that Y variables, you'll see Y1, Y2, Y3, Y4, Y5. You just pick wherever you want to put that. So if you're in your integral, and you put the integral from A to B, and then you would just do vars, Y vars, and then pick whatever one you got, whatever one you want, and that will put that Y1 in where you want it to go instead of having to type out the whole equation. And as I said, on this problem, it's not that big of a deal because the equations aren't that long, but it really does help when you have some pretty, really long equations. I always tell my kids to always use the Y bars, because then you don't have to worry about, typing in the equations incorrectly. Okay, did you get a volume here? And you probably can leave pi in your answer. A lot of times they do. Okay, so here's the setup. I mean, it's set up exactly the way we have it. They typed in the pi. So let's see here, were your values correct? Yep. The 0.15 and 3.146. Yep. So here's our equation, or here's our answer. It should be like 34.198 if it's plugged in correctly. And that problem was worth 3 points. Okay. Now, the last one, okay, part C, it's a little tricky, okay? So part C, it says write but do not evaluate an integral expression that can be used to find the volume of the solid generated when R is rotated about the y-axis. Okay, the y-axis. That means that this is my large R, this is my small r. So small r, large R. The only problem is you have to rewrite the equation. So this equation here was y is equal to x minus 2. That one's pretty easy to rewrite. It's going to be x equals y plus 2. Now this one over here, this equation was y is equal to natural log of x. Well, a lot of students, they don't know how to rewrite this as x equals. Well, remember, natural log is log base e. So I would rewrite it as y is equal to log base e of x. And then I would rewrite this as e to the y is equal to x. So that is how I would rewrite it. So now, if I was going to write this equation, and I forgot what you said the values were, so now we have to use the y values. So I would go from negative 1.841 up to 1.146. Large R is going to be y plus 2 squared minus small r, which we said was e to the y squared. And it says write but do not evaluate to find if we rotate it around the y-axis. Does that make sense? That when we're rotating around the y-axis, now what if I put it out here? What if I said in this problem, right here. Let's say I said I want you to rotate it around. Y is equal. This equation would be x equals -3. What would be the only thing that changes here? Well, my radiuses would become longer, wouldn't they? How much longer? 3, right? So I would just add 3 to this, but I'm not going to change it. But so do you see how rotating it around the y-axis or the x-axis or any other vertical or horizontal thing, you're just going to add, you know, that distance or subtract. If it was over here, okay, so if they wanted us to rotate it around here, this is the one where you'd have to go right minus left. So now this would be, let's say this was y is equal to 10. So this would be 10 minus, what is my large R now would be e to the y squared minus, and then this would be 10 minus, what was that, y plus 2. So it doesn't matter where you are rotating something around. You just have to, it's always large radius minus small radius. That's it. Okay. So let's see if we got that one right here. So that was part C. Part C, I don't know why they put s minus 2 or t minus 2. It's just the y values. And then y plus 2 squared minus e to the y squared. And that was 3 points for that. 3 points. Oh, I forgot. They probably would have nicked me a point because I did not put, like I always don't, I didn't put the pi out front. That is important. You need that in there. Okay, so that is the new material for this week. Why did they subtract 2? I have no idea, because that's I have no idea. This is what you should have there. You should have your y values. Now, is that minus 2? It sure is. 3.14 minus 2 would be 1.14. Huh? So those values, now, would you get docked if you put the exact values down? No, because they gave us the exact values up here. See, they gave us the 1.15 and the 3.14. Oh, I suppose they didn't give us the y values, but you can put the y values in there because it is 3.14 minus 2, which is 1.146. So I didn't notice that it would just be minus 2. So, but you could put the exact values in like I did. That is perfectly fine. Okay, so those are the types of problems that we're dealing with. That is the last new material that we have in calculus. It's basically finding volumes of rotation using what's called the washer method. Okay, does that make sense? Okay, we're also this week reviewing related rate questions. So let's talk about a related rate question. Related rates is when one thing is changing. So and you'll see most of the problems are ones that we've done before, because I always just want to make sure that you remember these types of problems. So in this problem, it says a railroad track and a road cross at right angles, and observer stands on the road 70 meters south. Okay, so I'm going to put this guy here. He's 70 meters south. We'll put a dot right there. Okay, and watches an eastbound train traveling 60 meters per second. So this train is going this direction at 60 meters per second. So let's call this x here. So what did they just give me? They just gave me dx dt, and that is 60 meters per second. It's how fast it's going. At how many meters per second is the train moving away from the observer? So here's the observer. And we want to find, let's call this y. We want to find dy dt. How fast, at how many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection? So I need to find out what y is equal to. I need to find out what x is equal to. Well, if the train is traveling 60 miles per hour, let's just go miles per hour, for 4 seconds, I guess it's 60 meters per second, for 4 seconds, this train has traveled 240 meters. Okay, so this value here is 240. This value is 70. This value y, I'd have to use my calculator, and I'd have to figure out what y is equal to. So 240 squared plus 70 squared, let's see here, is equal to, and then, oh, my calculator was turned off. All right, so let's go 240 squared plus 70 squared, and then take the square root of that. So the square root of 6,250, 62500 is 250. Okay, so this value is 250. Okay, so I have all these values. I just have to figure out what dy dt is. So remember, we set up an equation. So a squared plus b squared equals c squared. I'm going to call this side a, and this side b, and this side c. Now, a is a constant. It doesn't change. So remember, we could just cross it off. We don't need that. It's gone. My marker's not working here. So I'm going to cross it off. So this is going to be 2b. And remember, anytime we're doing related rates, you take the derivative, and then db dt is equal to 2c dc dt. Okay, so remember I changed this to b's now. So this is going to be 2 times 240 times the rate that it's traveling, that's 60, is equal to 2 times c. Well, our c value was, I can't read that anymore. I think that's 250. And then dc dt. And that's how we set up a related rate question. So a related rate question, remember, the key to these types of problems is making sure when you take the derivative, you tack on the the dA dt or dx dt or whatever it is. Does this ring any bells? This is probably back in first semester. That's why we're reviewing these types of problems. Oh, awesome. And then we also have rate at which questions. These, every single year, there is a rate at which question on the AP test. And they're so obvious. I mean, every year you'll see one. This one, it says the tide moves sand from Sandy Point Beach at a rate of, and then they give you a rate, and a pumping station adds sand back to the beach. One year it was snow was falling at a rate of, and Sue was shoveling the snow off of the sidewalk at a rate of. So, and one year it was the number of, it was like something with bananas, the number of bananas on a store shelf was changing at this rate, the person was stocking at this rate. So they're all very, very similar, okay? These are the types of problems where I tell students, plug this into your calculator right away. Put this in as y1, okay? So I want you to do this right now. I want you to put in y1. I want you to put this function 2 plus, because you're going to be using them all the time in every question. So sine of 4 pi t over 25. And then in y2, I want you to put in 15t over 1 plus 3t. Now, make sure your calculator is in, what mode do we want? We don't want degree, we want radian mode, okay? Do not put your calculator in degree mode when you're dealing with problems like this, because it's always radian. All right. So thumbs up when you get both these equations into your calculator, because we're gonna use the y variables pretty soon. Okay, so now part A, it says, how much sand will the tide remove from the beach? So there's a couple different types of questions they ask you on here. Total, like this is total something, total area underneath the curve. This is an integral. It's either going to be an integral or a derivative. This one definitely, because it's asking you how much is being taken away. So how much sand will the tide remove from, well, I better read the first part. Okay, it says, both RT and ST have units of cubic yards per hour, and T is measured between 0 and 6 hours. At time T is equal to 0, the beach contains 2,500 cubic yards of sand. Okay, pretty important. Whenever they give us a starting point, that's important. It's going to come up later on in the problem. Okay, so how much sand will the tide remove from the beach during the 6-hour period? Okay, so the tide removes sand. So that's my y1. So I'm going to do integral 0 to 6, and then I want you to just plug in y1. I want you to see if that works. Okay? Use your calculator, see if you can find the value for that. And 31.81. 31.81. Awesome. See how easy that was? Were you able to just do the integral and then put y1 in there? Exactly. And it's like you're not going to make a mistake plugging the equation in so many times. That's why I always tell kids, go to y1, y2, plug those values in right away, because then you can just use the equations anytime you want. Okay? Now, part B, it says write an expression for y sub t, the total number of cubic yards of sand on the beach at time t. Okay, so I'm going to let you think about that one. Stew it over. There is no work in this problem. Nothing. There's no work. You don't have to use a calculator. It just wants you to write an expression for y sub t, the total number of cubic yards of sand on the beach at time t. So we don't even know what time it is. It could be time 1, it could be time 0, it could be time 3 hours, 4 hours, 5 hours. We don't know, but we just want to write an equation for that. Okay? So it's a little tricky, but I'll let you try it. See if you can come up with an equation for that. S of t minus r sub t, or the integral of S of t minus r sub t. Very good. You're thinking on the right path here. Now, you did miss something very, very important. The 2,500. The beach starts at 2,500, so I'm going to need that. So how much, write an expression for the total number of cubic yards of sand on the beach. So I know it has to be 2,500 plus the amount the pumping station adds. So I could say plus the integral of S of t minus the integral of r sub t. And that, now we don't, and they might, you could put 0 to t here because you don't know what that is. I'm not sure if they had that. Let's take a look at the answer key. But there really wasn't any work here, was there? You just had to think about, okay, what's really going on in this problem? Okay, I've got sand that's going onto the beach. I've got sand being taken off of the beach. The integral really tells me how much is going to be there, right? Okay, so the integral will always tell us how much is going to be on that beach. So y sub t is equal to 2,500 plus 0 to t of s of x minus r sub x. Now, you could have written this as, remember, you can break integrals up. So I could have just put, this is perfectly fine right here. So there really wasn't any work. It was just, could you understand what they were asking you for? Okay, does that make sense? Are you okay with that problem? Okay. Part C, it says, find the rate. Okay, now, these problems R sub t is the rate of which something is happening. This is the rate that the sand is being pumped onto the beach. That's why when we take the integral, it gives us the total amount of that. So these are really derivatives, aren't they? They're the rate at which something is happening. So it says, find the rate at which the total amount of sand on the beach is changing at time t is equal to 4. Okay? So when I look at a problem like this, well, I'm gonna let you try it first and see what you get. Okay? But when you see the rate at which question on the AP exam this year, and there will be one, I guarantee you have to remember that those functions that they give you, those are the rate functions, so they give us how fast something is happening. But if I want to know total amount of something, I have to take the integral of that. Okay? And you'll see on this week's assessment, I have a couple of these types of problems, and they're all very similar. I mean, you'll see. All right. So in this problem, I see time is running out. So in this problem, what I would do is the derivative of y sub t, because that's basically what you're doing, right? You're just taking the derivative of the y function. So it's just going to be s of t. My marker's not turned on here. So it's just going to end up being s of t minus r sub t. Now, since you have the values in your calculator, right? You have y1 and y2 in there. You should be able to just go to the table and plug in, what was it, at time t is equal to 4. So you should be able to just plug in 4 and come up with your answer. Okay, and I didn't plug these into my calculator. So what do you get if you do s of 4 minus r sub 4? What did you get? How do you plug it into the table? Okay, do you have y1 and y2 in y1, y2? When you had, when you're looking at your okay, so when you go to your table, second table, oops, I got to turn my calculator on. You're asking, because sometimes it's automatically values are put in there, right? You want to know how to put in a specific value into the x. Is that what you're asking? Okay, you got it? All right. So what is s of 4 minus r of 4? And we'll just go to I think this is what they came up with. So you can just look at the answer there. And then the last question, because I got to get going real quick here. The last question was something about between 0 and 6, at what time t is the amount of sand on the beach? A minimum, what is the minimum? Well, that you have to check out endpoints. So you have to check out time t is equal to 0, time t is equal to 6, because those are endpoints. Well, I know how much sand is on the beach at time t equals 0, 2,500. T is equal to 6. You can just plug in. I don't think we know what it is. Did we find? Oh, we found that in part A, didn't we? Oh no, we found out how much would be removed. So you're going to have to check each point and where it matches. So this is part number 6 here, or part D. So you can take a look at that. But it is 3 o'clock, and I've got another class. All right. So take your time on this week. Try your best. All these types of problems you're going to see in the near future. All right. You guys have a great week. Bye.